Hello learners, and welcome to today's lesson of Geometry of 2D Shapes, Parallelograms. So today we are going to be focusing on those practice and application questions. Let's get down to our questions. So the first question there says, list the properties of a square in terms of its sides, angles, and diagonals. So can you list the properties of a square? Let's think about a square quickly. Well, the first thing that we know is that all of the sides are equal. So if we label the square that we have drawn here is A, B, C, and D, then we would know that AB is equals to BC, and that is equals to DC, and that is equals to AD. So we can write there that AB is equals to BC, and that is equals to DC, and that is equals to AD. So all of the sides are equal. Another thing with the sides is that, or another property with the sides is that the opposite sides are parallel. So AB is a parallel to DC, and of course AD is parallel to BC. So those are the sides of a square. What about the angles? Now, when it comes to a square, we know that the angles are equals to 90 degrees. So all of the angles are 90 degrees, and when we add those angles up, they are going to give us 360 degrees. So we know that all the angles, so that is angle A, is equals to angle B, that is equals to angle C, and that is equals to angle D. And they are all equals to 90 degrees. Now, if we were to add these angles, so that's angle A plus angle B plus angle C plus angle D, we know that the sum of those interior angles is equals to 360 degrees. And that is with the angles. What about the diagonals? Now, with a square, the diagonals of a square, they first of all bisect each other. So the diagonals of a square, they bisect each other. So remember, a diagonal is a straight line from one vertex to another vertex. So we've got diagonals DB and we've got diagonals AC. And let's say that where those two diagonals meet, they meet at T. So what does this mean? It means that AT is equals to CT. It also means that DT is equals to BT because those diagonals bisect each other. Now, they don't only bisect each other, but they also meet at a right angle. So they are perpendicular to each other. They meet at 90 degrees. So those are the diagonals. And the last thing that the diagonal does, well, let's write that property down. So that is AC is perpendicular to DB. And the last property concerning the diagonals of a square is that they bisect the opposite angles. So that means that AC bisects. So that means that AC bisects angle A and angle C. And also DB bisects angle D and angle B. So since as well we know that the angles are 90 degrees, we know that angle C is 90 degrees, that means when bisected, it is equals to 45 degrees each. So that would mean that that angle there would be 45 degrees and that angle there would be 45 degrees. Now the same would apply for all of those angles since they are all bisected by the diagonals. And those are the properties of a square. So what about the length of AC and the length of DB? Remember, those are our diagonals. So what do you know about the diagonals of a square? Of course, besides the fact that they bisect each other, but they are also equal. So this means that AC is equal to DB. Let's move on to our second question. It says they list the properties of a parallelogram in terms of its sides, angles, and diagonals. Now, when we think of a parallelogram, the first thing we can think of is the parallel sides. So let's label our parallelogram here PQRS. So a parallelogram, firstly, we know that it has two pairs of opposite lines that are parallel. So that means that PQ is parallel to SR, and of course PS is a parallel to QR. So PQ is parallel to SR and PS is parallel to QR. What else about the opposite sides? They are also equal. So PQ is equals to SR and also PS is equals to QR. So the opposite sides are equal as well. So those are the sides when it comes to the properties. What about the angles? So when it comes to the angles of a parallelogram, we know that the opposite angles are equal. So that means that angle S is equals to angle Q and angle P is equals to angle R. So those opposite angles are equal. Then lastly, when it comes to the diagonals of a parallelogram, so the diagonals of a parallelogram, we have the SQ and we have another diagonal there, PR. So what do we know about those diagonals? Well, we know that they bisect each other. So if they are meeting there at M, then that would mean that PM is equals to MR, and it would mean that SM is equals to MQ. And those are the diagonals of a parallelogram. So those are all the properties of a parallelogram in terms of its sides, its angles, and the diagonals. Let's move on to our next question. Our next question there also says, list the properties of a rhombus in terms of its sides, angles, and diagonals. Now remember, a rhombus is a special parallelogram. So a rhombus is a special parallelogram. What does this mean? It means that all of the properties of a parallelogram also apply to a rhombus. So let's label our rhombus there. That would be LMNO. So all of those properties of a parallelogram apply to a rhombus. That is, the opposite sides are parallel. So LM is parallel to ON and LO is parallel to MN. But because a rhombus is a special parallelogram, not only are the opposite sides equal, but they are all equal. So all of these sides are equal. That means that LM is equals to MN, and that is equals to ON, and that is equals to LO. So all of the sides of a rhombus are equal. What about the angles of a rhombus? Well, just like a parallelogram, the opposite angles of a rhombus are equal. So we have there angle O and angle M, they are equal, and angle L and angle N, they are also equal. So angle N is equals to angle L, and angle O is equals to angle M, because they are opposite angles of a rhombus. What about the diagonals? Now the diagonals here we have OM and we also have LN. So where they meet, so where they intersect, let's say they intersect at T, then we know that those diagonals bisect each other just like they did with a parallelogram. So what does this mean? It means that OT is equals to TM. It also means that LT is equals to TN. Now also, what makes a rhombus special is that those diagonals, they meet at a 90 degrees. And not only do they meet at a 90 degrees, they also bisect the opposite angles. So that means that those angles that we identified as being equal, they are also bisected, which means that that part of the angle will be equals to that part of the angle, and also that part of the angle will be equals to that part of the angle. Now, this will be the same for the other two opposite angles as well, which is angle O and angle M. And those are all the properties of a rhombus. And remember, those diagonals, they also bisect each other, and they're perpendicular to each other, and they also bisect the opposite angles. What about the properties of a rectangle? So when asked for the properties of a rectangle, remember a rectangle is a special parallelogram, which means that all of the properties of a parallelogram apply to a rectangle as well. What does this mean? It means that the opposite sides are parallel. It means that let's label it quickly, A, B, C, D. It means AB is parallel to DC, and AD is parallel to BC. And also, the opposite sides are equal. So again, AB is equals to DC, and AD is equals to BC. But what makes a rectangle different from a parallelogram is that the interior angles of a rectangle are known, and they are 90 degrees. So in a parallelogram, yes, the opposite angles are equal, which is also true for a rectangle, but we know that the angles here are 90 degrees. And lastly, when it comes to the diagonals, of course, we know the diagonals bisect each other, but what makes a rectangle different is that the diagonals are also equal. So this means that AC is equals to DB. And of course, the rest of the properties that apply for a parallelogram also apply for a rectangle as well. Let's quickly go to an ad break, and then we'll see you just now for the rest of our lesson.